In this video, we will analyze the gameplay Fibonacci Nim. The Fibonacci Nim game involves two players and involves a pile of objects. To start thinking, we'll start from the first player. The first player will take at least one object, but not all of the objects from the pile. And then the second player will take at least one, but no more than double objects than the player 1 removed. Now it's player 1's turn. Similarly, the player 1 cannot take no more than double objects than the player 2 removed. The game continues in this way, and the player who takes the last objects will win. Let me show you an example. There are 7 chips. Assume we have known the winning strategy. The total number is not a Fibonacci number, and the first player just breaks the 7 into 2 non-repeated Fibonacci names, and then the first player will win. So the first player will break the 7 in 2 and 5. According to the ring, the first player can remove 1 to 6 chips. If she removes 5 chips, the player 2 will win the game. So the player 1 will choose to remove 2. There are 5 chips left. Now it's player 2's turn. He can choose to remove 1, 2, 3, or 4. But when he chooses to remove 2, 3, or 4 chips, the player 1 will win. So he has only one option. The player 2 is forced to take only 1 chip. There are 4 chips left. Again, the first player will break the 4 into 1 and 3, and she will take 1 chip. There are 3 chips left. The second player will only have 2 options. Remove 1 or 2 chips, but neither way the player 1 will win. So let us to have a look at the proof. We denote the first player as P1, the second player as P2, the total number as n. Situation 1. N is a Fibonacci number. When n is equal to the 2, then the P1 must lose, since P1 can only take 1, and then the P2 will take another one, and P1 lose, and P2 will win. If n is greater than 2, we will apply mathematics induction. Denote A1, A2, and so on as the first I Fibonacci numbers, starting from A1 equals to 2, A2 equals to 3, and so on. AI minus 1 plus AI equals to AI plus 1. We assume that when n equals to the first I Fibonacci number, the first player must lose. Claim when n equals to AI plus 1, the first player will lose as well. There are 3 situations. For the first situation, if m greater or equal to AI minus 1, since AI equals to AI minus 1 plus AI minus 2, which less than the 2 times AI minus 1. So the second player can take all the rest of the objects. The first player will lose, and the second player will win. At the second situation, 1 over 3 A ai minus 1 is less or equal to ai minus 1, equals to m and less than ai minus 1. For the first round, the second player can take all objects remaining in the ai minus 1, so the first player will lose. Or in the first round, the second player takes x objects in this round, and x is greater or equal to 1, which is less and equal to 2 over 3 ai minus 1. And in the round 2, suppose P1 can take y objects, then y greater or equal to 1, less or equal to 4 over 3 ai minus 1. So we can have a look at this equation. According to the equation, the first player cannot take the rest of the objects at a time in round 2. So the first player will lose and the second player will win. And for the third situation, the second player cannot take ai minus 1 at a time, so there are at least 2 rounds. For the first round, according to the assumption, there must exist one way to ensure the second player takes the last object from the ai minus 1. And in the second round, after taking all ai minus 1 stones, it's the same as the objects. I think I make a mistake. If the first player cannot take ai at a time, the assumption stands, and the second player will win. Otherwise, if the first player can take ai at a time, then the second player must take at least the half of ai when taking the ai minus 1 objects. And according to this equation, the first player and the second player, they remove the objects greater than the ai minus 1. So there will not exist one way to ensure the first player take ai at a time. So the first player must lose. In a summary, if n is a Fibonacci number, the first player will lose and the second player will win. So after discuss about the situation 1, we will discuss about the situation 2. N is not a Fibonacci number. There is a theorem stated that every positive integer can be represented as a sum of one or more distinct Fibonacci numbers. That the sum does not include any two consecutive Fibonacci numbers. So, the first player can take ai at a time because these Fibonacci numbers are inconsecutive. So, the ai2 greater than 2 times the ai1. So the second player has to take from the ai2 but cannot take them all. According to the situation 1, the P1 can take the last one from the ai2. By that and logging, the second player will lose. The first player will win. So that's all for the proof. Because I think my English is not very well, but actually I spent a lot of time to prepare it, and at last I want to say the game is full of logic and life is full of mathematics. If we use mathematics, we can win game. Also, we can lead a colorful life. Thank you.